Okay. So this is the beginning of, number crunching, basically, and few important concepts. They start from right here, and those concepts are very important throughout the statistics, not only this course or anything that you do using data analysis statistics. Those concepts will be useful throughout the life. So we are going to work on those. I'm just going to open my mini tab and we'll start. Uh, so this is a numerical description. In the last class, we spoke about uh, visually, describing data visually. Now we are going to learn describing data numerically. So this is again descriptive statistics. What do we do here? We normally treat one variable at a time. One variable at a time, that is descriptive. But in correlation, we treat two variables together. So this is important here. One variable, only one item, which is two variables together, is correlation. So again, why we are doing this? To understand where the values are concentrated, where is the center, how it is bearing, what is the dispersion, how it is dispersed, uh, how spread out are the data values, are the values are unusual, shape, are the data value distributed symmetrically, skewed, sharp, peak, flagged, bimodal, all the things. So this is the uh, all three items or three properties we are going to look into: center, variability, and shape. So as you know, what is mean? Mean is nothing but an average, and the average. It's a So mean is simple. Again, the notation is, you can understand here, mu is for population, x bar for sample. So always remember, whenever mu is given, that means they are asking population mean. Whenever x bar is giving, they are asking about sample mean. What is median? Median is 50th, if you divide or if you chop, let's say, uh, if you have a data, this is data, you arrange the data in order. It has to be arranged in order. And the exact center point where you chop the data into two pieces, this point is called median. So this is median. We already learned in our, you know, what is the median. And then mode. Mode is most occurring data value, or most occurring frequency is called mode. So mode we have already studied. So now look into the very important part here. So think about this. When mean equal to mode equal to median, that is a very ideal situation. This is means you will get identical symmetric normal distribution. Wherever you will see this situation, you can blindly say the data is perfectly normally distributed. Or ideally this is practically not possible, because you can't have exact same number for mean, mode, median if you are treating large amount of data. What you can say, if they are close to each other, they are close or approximately equal to each other, you can say this situation. Now another situation you can also handle, you can also know if mode is higher, mean is lowest, median is between, you can understand this is skewed left. If mean is higher, mode is lower, and median, you can say skewed right. So basically what this is the ideal condition that is uh, needed, or this is what is desired from most of the organization when they treat the data. So this is, you can basically, mean, mode, median can also explain you, or explains the shape of the data. So the, these three items, mean, mode, median, is about center. Also explain the shape. And now, oh, I have to. Now, another important thing is, geometric mean. Normally we understand, average or simple mean is good for taking the, average growth rate or financial performance rate. But that is not, correct way. Suppose, the GDP of this year, next year, this year is 3.2%, next year is 3.4%, following year is 3.4%. And if you have GDP of 5 years, and you are going to check, what is the average growth rate, then don't take the simple average. What is the way to do this? This is the example. The geometric mean is the one which helps you to understand the average growth rate over financial performance or economic performance. And the formula is like this. And we can simply understand through this. Measure of center in 2006, this is the revenue, this is the revenue, this is the, 5 years revenue is there. What is the uh, jet blue? So what is the growth rate? This is because there are. So if you put these numbers here, and you will normally get the last and the first. So basically what you need to do, last, directly put the last value divided by the first value and a square root of 4, because there are going to be 4. So how -1. So what is the value? 4 times square root, and 3779 is the last value divided, and -1, which is, this is coming 0.125, which is 12.5% per year. So, and in normal way, if you look into this, revenue, and if you take the average, and which is not the true measure of average growth or average thing. Therefore, this is the geometric mean is the method to apply whenever you do any financial, any economic average of the indicators, then use this. So this is has, because of finance and other things. Mid-range. What is mid-range? Halfway between two. So highest value and lowest value plus lowest value divided by 2 is mid-range. So I will, now we are going to check the variation. And here you have to put your focus, because we are going to learn standard deviation and variation. And it is very important. It has wide application throughout the statistics. So what it explains is spread of data points about the center of the distribution in a sample. And first thing, what is the range? So variation, how you can understand, maximum minus minimum value, that gives you the range. What is the range of age of the passenger on Titanic? So basically it starts from, I think, 0.18 to 70 years. So basically 69 point how much, 69.82. This is the range of Titanic passenger age. We can do all the things, in one click on Minitab, but I would like to, put attention here about the concepts. Once we understand the concept, it is easy. Minitab is just a calculator. It is just gives you, to calculate, but most important is interpretation. And we are not learning here Minitab. To be honest, I'm not teaching Minitab. My purpose is just you understand the concept, and we have different tools. You can prefer Excel, you can prefer any, SPSS or different other tools are there. So concepts are. Now look into the what is the variance and what is the standard deviation. So I'm just going to explain you through through 1 minute, a whiteboard. Okay, here we go. I'm just taking 5 numbers. Okay, for example, this is the age of students in my class. I'm just taking, they are just for easy number. I'm just going to take 5, 6, 4, 7, 8. These are the 5 students in my, kindergarten class, and their age is 5, 6, 7, 8. 4, 5, 6, 7, 8. 5 of them are there. What is the average of this? So if I take, what is the sum of 8 plus 7, 15, 15 plus 50, 30, 30 divided by 5. So X bar is 6, because this is 30 years. Okay. Now let me subtract this with 6 minus 6 minus 6 minus 6 minus 6 minus 2, minus 6, sorry. What value am I going to get? Minus 1, 0, minus 2, 1, and 2. Now let me do the sum of all these things. This is going to be 0. Therefore, it will not make any sense. It will not make any sense. Now look into this. Second thing, so what I need to do, I need to treat this data. How I can, avoid 0? There are 2 ways to avoid. Either I can take absolute value or I can take a square. In both cases, I can avoid this 0. So let me do first absolute value. Absolute value, whatever is the sign, all the values will be positive. Or so minus 1 is absolute value. So I'm just going to put there absolute values. So this is 1, this is 0, this is 2, this is 1, and this is 2. What we are going to get here? 6. So I can write here. So this we will take care, later on, because we can understand mean absolute deviation. So this is 6. Now let me do the x square part, square of these values. So minus 1 and 1, minus 1 square, minus 1 into minus 1, 1. 0 remains 0, minus 2 and minus 2, 4. Here 1 and 4. So we get 10. Okay. Now the formula is, we have the formula right here. Where is the square divided by n? So yes. So now the formula is this divided by n. So sigma square equal to 10 divided by n number of items. How many n are there? So I'm just putting 5, because we have 5 numbers. So there's a difference between sigma square and s square. So if I do s square, means this is for population, this is for sample. What would be 10 divided by 5 minus 1. What value we are getting here? Sigma square is equal to 2 and S square is equal to 4, 2.5. So sigma square is known as variance. So this is a variance of population. This is a variance of sample. What is the standard deviation? Standard deviation is equal to square root of, I just removed this square sign. So this would be square root of 2. And S equal to square root of 2.5. So this is a calculation. That means here we see this sigma square or sigma. What is the difference between variance equal to? This is a relationship in most of the cases, most of the examples. If variance is given, you can calculate, you can just do square root of, then you can get the standard deviation. Standard deviation square, SD square. So this is the relationship, or vice versa you can do, or standard deviation. So this is the formula you can. Now let's look into the one more situation. Okay, let me go with next. So this is clear. I'm just going to erase this part. This is, for example, this is 6 absolute value. So let me go with this also. Uh, here. So this is population variance, and this is sample variance. This is population standard deviation, and this is population standard deviation. Now look into coefficient of variation is 100 multiplied by S divided by S means sample standard deviation, X bar means sample mean. This is called mean absolute deviation, equal to this divided by N. So what is the mean absolute deviation that we are going to get in our case here? So I just go again on whiteboard. So mean absolute deviation equal to 6 divided by 5, which is 1.2. So we get all three values here. Now let's try to understand the interpretation of this. What about if all the ages, let's say I just erase this part, and let's do this. If my class is distributed in a manner that all the ages are same, students age, oh, okay, let me do this. So let's say if this, I have 5 students, their age is like 5, all are of same year. Okay, what would be the average? Average would be 5. So 25 is the total age. If I subtract 5 with 5, 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 what am I going to get? 0, 0, 0, 0, and 0. And if I take the absolute value will be 0, again 0, 0, 0, and 0. let's say if I'm going to take a square of the, this thing, 0, 0, 0, 0, 0. If I'm going to do variance, then variance is also 0. If I'm going to do standard deviation, 0. If I'm going to do mean absolute deviation, 0. Everything is 0. Now I'm coming to the application part of this. So I normally give the example of, runway of the airport. Let's see, this is a runway of any airport. Okay. This is the runway of any airport. Most of the flights, even they take off or land, they follow this. Their front landing gear is always on this. Suppose this is a 0th condition. A condition is, the landing gear is here. B condition is landing gear is here. And C condition is, just, try to understand, this is more closer. This is C condition. So these are the three planes landing or taking off. The first condition is this A, the B is this, C is this. So the distance from mean, which is ideal condition, first of all, ideal condition, it has to land on the the line which is right there on the center of the runway. That is ideal. That means there is standard deviation because this is decided. The deviation from this is 0. That means no deviation. That means the flights are safe. This is deviating A. Now tell me which flight has highest risk? Which flight has the highest risk? I think C is, is the, closest to, this is C is the C flight has, because it is just, very far away from the central line. So the deviation, because the deviation from the mean is very high. The A flight, the 0th flight has no risk. A flight has minimum risk. C flight has highest risk. And B flight has the moderate risk. That means what we can understand from what is the interpretation of sigma and variance. Variance or standard deviation. What is your understanding based on this explanation and calculation? Any observation that, or any conclusion that you can draw about standard deviation or and variance? Okay, so let's do one thing. What is the ideal value of sigma? Ideal value of sigma is 0. However, practically that is not possible. Ideal value means best, thing. Practically in real life, that is not possible. A zero deviation, even flights or Six Sigma. I am going to come over this. Six Sigma is the philosophy that has been followed by aviation industry. They follow most of the flights. How many flights take off and land every day around the world? I think it's millions of, hundred of thousands of flights take off and land every day, and rarely you see anything. So Six Sigma is the philosophy. These aviation industry is following the Six Sigma practices. So ideally zero is not possible practically. This is ideally but practically not possible. So what is the best value? What is the best data? That data means your data is, if this is as close to as zero, the standard deviation value must be as close to zero. If that is as close to zero, that is this. Now let's go further. So what we can understand, higher the value of sigma or higher the value of variance means you have higher risk, or data is spreaded, or data is uh, uh, spreaded long range, or it has dispersion is high. If value of sigma or variance is lower than me, that means it has lower impact, means it has low risk. So this is the importance of sigma. If you understand these concepts, mean absolute deviation is another form of but which is rarely used in or which is not used as frequently as standard deviation or variance is used. So so this explains the variability. Lowest the value of sigma and sigma square is explain low variability. Higher the value of sigma square is high variability. So this is, now we go to the, what is standardized data? Standardized data is, so let me explain you the standardized data first, and then we will go for this empirical rule. So what is standardized data? Let's look into this. I'm going to take uh, okay, let me take something different. Okay, this is the data I have. So this is a data of international students getting admission in India.
I'm still seeing the whiteboard, so I'm not sure if
Oh,
that's what you...
sorry. Uh, yeah. So now hope you can see. And this is just data which I would like to. So
Yeah,
now
we
you.
can see it.
So basically, what is the standardized data here? If this is a ZRE score for MS admission or master's degree admission in US university, they need GRE. So I'm just treating GRE only one variable. Here, I don't know, what is, so this is a score, different scores of different 500 students score. So let's do the, what is standardization is just uh, Z equal to X minus mu divided by standard deviation. This is the individual value, which is X. Mu or X bar is average of entire data set here, and the standard deviation of all the entire GRE. Mu is the average of entire GRE. How we can do? So if X value is greater than minus average, or X value is greater than average, then Z value is positive. If X value is less than X value, a mu value, then it is negative, a standard deviation. So I'm just going to do few things here. I'm going to do graph, histogram, and just I'm going to do this. So GRE. So you can see what is the mean here. Mean is coming, mean is 316.5. Standard deviation is 11.30. Okay. Now if I subtract, so what would be the Z value of first part? First value 337 minus 316.5 divided by 11.3. So if we calculate this, we can get the standardized value here. Now this is the concept, and we have the option right here to do this. And since this is the bigger value than mean, so this will be a positive value. If suppose this is something like 314, so for example 314, this is a less than 316, this will be negative value. Now let me do the standardized value of anything. So I just put here, I'm going to get the standardized value in this column. Calculate. Here we have standardization option. Can you see this under calculate standardization? Here input column ZRE score, output column standard value, and we are not going to do anything. Just click here. Look into this is, for example, I said this is a bigger value. Here you can see this is positive value. Similarly, you can see 314 is negative value. So this is called standardized value. What is the importance of this? The importance is this: when you do the standardized value, its mean is always 0 and standard deviation is always 1. What is the, so this is a simple normal distribution. Its mean is 316 and standard deviation is this. But when you do this, you will get to know that it's a mean. So I'm now going to do this. So I go under graph, and where's histogram? I'm just going to do histogram. Okay. I'm going to choose now standardized value. So you can see standard deviation is 1, mean is approximately 0. Not ideally, but it is close to. So you can see mean is 0 here. You can see mean is 0. So this is a 0. This is standard normal days. From here to here, this is, and here to. So if anything is more than average, that will come on this side. Anything else, less than average, that will come on this side. These are the negative things. So this is called and. So this is 1 sigma, this is 2 sigma, this is 3 sigma. Mean plus one let me explain through slides, then I'm going to be here again. So hope you can understand the standardized value. Now share the screen. So this is a standardized variable. So if you see, and now I'm going back to, so this is a mu plus minus 1 sigma. Mu plus minus 1 sigma, how much value it will have? 68.26% of data will be within this limit. And there's also this rule. So here mu plus minus 2 sigma, 1 sigma, and 3 sigma, here at least 90 or 89% will be lie within mu plus minus 3 sigma. So basically this is the one thing. Plus minus 2 sigma, how much? 75% data will be here. So we are going to test ourselves. This is empirical rule. Within 2 sigma, 68%. Within 4 sigma, 94.44%. And within 6 sigma, how much? 99.73% data will be there. Now we would like to check practically this theorem is good or not. So I'm just going to use the same thing. I'm just going to remove all the things. So again, I'm just going to do histogram to know the mean of GRE. So 316.5 and standard deviation is 11.30. Let me do the range. So mu plus minus sigma. This has 68% or and mu plus minus 2 sigma. This has how much? 7, as per 95.44. This is based on empirical rule. Now I'm just going to do one simple calculus. Mu is 316.5 minus 11.30 to 316 plus 11.30. So this is 0.5. So what is the range we get? 316.5 to 1130. So how much it is? So basically 10. So 305, roughly I can take 305. So this value is 305. This value is 316.5 and 11. So 11, 27, 27 and 28. So 328. Within this range, how much 68% number should be here based on empirical rule? Okay, let me see. I'm just going to do manually. So calculate. I need to sort this number. Data. I have here the option sort. And I go for GRE score. And I need GRE score. I would like to know in increasing order. Okay. All columns, not specified columns. And I can go in column C11. Oh, sorry, I think I just did. at the end of current worksheet or a specified column. So at the end of current worksheet, I'm going to do this. Columns. Let me do all columns. So sorted. Here you can see GRE score. This is a GRE score. And let me see where we have the 305 number. Okay, 305 starts from 89th. Can you just see 89th numbers? So 89th entry is 305. And now I would like to see 328. So (320) is 426. 89 and 426. So using calculator, so 426 minus 89 or 88, sorry. 426 minus 88. 426 minus 88. 338. How many numbers are coming? 338. Out of 500, what is the value of 338? 338 divided by, because these are 500 numbers, what number we are getting? Oh, 338 divided by 500. 67.6%. So 67% of data is within 2 sigma limit. Are you with me? What I'm trying to explain? So you can see that 68.2 within 1 sigma, plus minus 1 sigma means 2 sigma. Similarly, you can do 2 sigma, 3 sigma. So this is a practical aspect that I wanted to explain through basic. Is it making sense?
So it's the first one, but that could be, but you're saying 2 sigma, and that's confusing me.
Oh, okay. So this is, you can see this is a mu.
Yep.
This is mu minus 1 sigma, mu plus 1 sigma. So this range is called 1 sigma this side, 1 sigma this side. So this range is totally 2 sigma.
Okay, I missed that. Okay, thank you.
And similarly here, minus 2 and plus 2. So this range is 4 sigma. Minus 3 and plus 3. So this is 6 sigma. So range, I'm just, within 2 sigma range, the 68.26% data. If you have a large amount of data, suppose you are dealing with a Amazon customer database, you will come across exactly around this 68% data will be in this range. Even with 500 data points, we are getting in this range using sigma value. So this is called empirical rule. Okay, if this is clear, this is a standardized variable mu minus sigma. Now how we can, so range of the data is equal to 6 sigma, means entire data will be 99.73% data, which is, you can say, entire data will be within 6 sigma range. So what is the sigma value? Sigma value, if you want to calculate the sigma value, you can also do this range divided by 6. How you can get the range? Highest value minus lowest value divided by 6, you get the sigma value. So if this is, now we are coming to another important part, which is called percentile. Percentile is percentile, decile, quartiles, quintiles. So a very simple explanation I would like to so for example, this is entire data has been arranged in increasing order. If you put this into two pieces, 50% is here data here, 50 is here. If I take the two parts of this, 25 is here, 25 is here, and same I do here, 25 is here, 25 is. So this is called quartiles, means up to here is quarter one, this is quarter two, this is quarter three, this is minimum value, this is maximum value, and these can be represented using box plot is the diagram through which, or graph you can. So this is first 25%, this is next 25%, this is third 25. So basically this is similarly, if I take this data, I chop into 100 equal pieces, means if here to here, I just I assume these are 100 pieces I have done. These are called percentile. 100% means you chop this data into 100 equal parts, that is called percentile. Suppose I chop this data into 10 equal parts, that is called decile. That is called, so percentile if you divide the data into 100 equal parts, decile if you divide in 10 groups, quintiles when you divide into 5 equal groups, 20% of 5, quartiles when you divide into 4 groups. So this is percentile data, and this is just explanation. Now we would like to use, so box plot is the one thing which gives you the 5-point summary: minimum value, maximum value, quartile 1, quartile 2, quartile 3. So, and what is the interquartile range? Interquartile range is middle 50% of the data. Q1 to Q3, this range is interquartile range. So below, this is below 25%, this is top 25%, and this is middle 25%. So this is, so when you have this kind of thing, you can understand the data is normally distributed. If you see the box plot is towards right side, skewed left, box plot is towards left side, skewed right. If you see, this is uniform distribution. Mid-hinge, not, and then we have a correlation coefficient. Correlation coefficient, so correlation is when y value, these are two variables, when you plot together, x value is increasing, y value is increasing. This is positive correlation. R, when you see the not proper relationship, this is moderate correlation. This is 0 means no relationship. This is negative, x value increasing, y value is decreasing. This is negative correlation. This is moderately negative correlation, and this is no correlation. So correlation value starts from -1, goes up to +1, -1 to +1.
Are you showing? We can't. Are you showing the slides?
Oh, sorry. I think. Okay, just a minute. Oh, I thought.
There we go.
I'm sorry,
good.
because I just I thought.
You get excited. I get it.
No, actually, you need to keep, when you're teaching this number crunching, you need to be very focused on on numbers.
Yes.
And always, when I'm teaching, these numbers and formulas, everything is in brain. So probably I don't recall what I'm doing, So it is difficult to focus on 2-3 different, because I have to open calculator, this and that, switch the mini tab and this. Anyway, So this is correlation. Here you can see if one variable is increasing, another is also increasing, and then you plot this, this is positive. If one variable is increasing, other is decreasing, that is negative correlation. So let's see, at the early age of the life, for example, your age is increasing and then your salary is increasing. It's a positive correlation, or in any organization. If this is a moderative, this is R equal 50.50. Zero means no relationship between age or salary. Here your age is increasing but salary is decreasing. That is negative correlation positive. But your age is increasing, salary is moderately decreasing. This is negative correlation. Moderately negative, and this is no correlation. So this is these things. Covariance is also here. This is the formula. Two random variable measure the degree of which the value of x and y change together. This is covariance, how they are varying, with respect to each other. This is covariance. And this is a formula. Then skewness, what is the skewness? If skewness value is less than 0, that is left skewed. If more than 0, skewed right. 0 means no, normal. Similarly, kurtosis, if this is less than 0, means heavier tails are there. If 0, normal peak is there. Greater than 0 means highest, bigger peak is there. So this is what is about chapter 4, but we are going to do a lot of things on Minitab. Here we go. I think you can see now Minitab.
Yes.
So remember one thing, where we get all these numbers. Go under statistics. Now we are go under basic statistics. Under basic statistics had display descriptive statistics. Okay, I'm just picking, only GRE. Here under statistics, you can see all the things that we have just studied: mean, standard error of mean, standard deviation, coefficient of variation, first quartile, median, third quartile, interquartile range, mode, trimmed mean, I'm not, range, skewness, kurtosis, and okay, so basically I think we have only covered these things. In one click, we can get all these things. Look into this. For GRE, mean is this, standard deviation is this, variance is this, the relationship between this, coefficient of variation 3.57, minimum value is this. Q1 means where 25% limit, minimum is 290, Q1 is 308, 50% limit, median is 317, Q3 is 325, where 75% data is there, highest value is 314, range is 50, means highest value minus lowest value, so highest 340, lowest is 290, the range is 50, interquartile range, Q3 minus Q1, so 325 minus 308, 17 is interquartile range. What is the mode? 312. That means how many times 312s are coming? 24 times. Now here you can see skewness is minus 0.04 and kurtosis is minus 0.71. What you can understand from this? It is left, so these values are here. You can simply, so kurtosis is less than 0. This is platykurtic, means it is heavier tails are there. So the kurtosis, you can understand this kind of shape is there. This is also, less than 0. That means tail is towards left side, skewed left. More values are towards this side. So this is, so we can do everything right here. Just a minute. So we can do all these calculations right here. Now we have a question. Here we go to statistics. Here we go to graph. Under graph we have box plot. So I'm just going to use box plot. Okay, I'm going to use again for GRE. So here you can see this is the box plot. You can see Q value is 308, median is 317, Q3 is 325, n equal to 500, and this is GRE. Sorry. So highest value 340, lowest value 290. So it is representing 5 number summary, which is edit inter. So you will get all the options here, right? Hinge, percentile, box proportions. You can have many options. So basically, it gives you 5 number summary. So box plot. Now we are coming to the percentile part, that how we can do the percentile. Go under graph. I'm just going to go over graph. And we have probability distribution. Box under this probability distribution, we have view probability. Okay, look into this. So standard normal distribution. What is the standard normal distribution? Mean is 0 and this is always 1. Look into this. Now I'm going to see the probability x values, and this is a probability and x value. So I'm just going to use this, and just a minute. So I can do with using this. So this is, now I would like to see what is the value of 68% in, or I can do here x value. I can put left tail, right tail, middle tail. So I'm just going in terms of probability, and here, so this you can see this is a 0. I think this is 1.645. This is the value of, so basically what is coming here, 95 percentile is here on the back side and 5 percentile is here. So somebody who is having 1.645 in on a standardized score will be 95 percentile. So now I would like to check the percentile in GRE thing. So let's remember 316.5 is mean, standard deviation is 11.3. Graph, probability distribution, here going here, instead of normal I am going to use these numbers, 316.5, 11.3. You got it? So these are the number. Now I would like to know where the 95 percentile cutoff or 95 percentile, or where the 95 percentile, what would be the 95 percentile of this GRE. So look into that. So this 335.5, we use the this, those who have scored 335 or plus, they will be about 95 percentile. They will be in top 5 percentile. Those who have scored 335 or less, they are under 95 percentile. 316.5 is 50 percentile. Are you getting the point? How do we do the percentile thing?
Yep.
Similarly, suppose okay, based on that, I would like to know if I scored 330, how much 330, what would be my percentile value? So I go here, I use exactly the same. This is the thing. I'm going to use X value and I'm going to use this. 330 is my GRE score. I would like to know in what percentile I am in. Okay, 330 is here. So how much? 11%, 11.61 percentile is here. How much percentile is here? Roughly you can say 88 percentile is here. So I can say I'm in roughly 88 percentile of the entire GRE. Similarly, we do the calculation. We will do this a lot in I think chapter number 8. So if you know mean, if you know standard deviation of entire data, and if you know the particular value, you can get in what percentile you are in. Or vice versa, you can also get, I would like to know this using this data, what is the cutoff limit of 90 percentile? What is the value? What is the GRE score which indicates the 90 percentile? So I go again here, and here instead of probability, and I use the 90 percentile. So I can use the 90 here, 0.9. Let's go. So this is the 300, those who have scored 331 plus. So 331 is the cutoff of, if anyone is scored less than 330, if anyone is scored 331 plus, they are all about 90 percentile. So if you know mean and standard deviation, you can do all the, these types of calculations. I think this is what I wanted to cover this week, and assignment, quiz, everything is right there. Any question do you have related to this chapter? All the calculations can be done using only one thing, which is statistics, basic statistics, and descriptive statistics. And when you pick, you can select the calculation that you want to do, and all here in one click, in less than 1 minute, you can do the calculation. So this is, but understanding interpretation is very important. So whatever I taught or explained, that can be done in less than 1 second. But on the top, understanding and thinking is important. Any other question? If you have, please let me know. Otherwise, this is what I wanted to cover. Thank you so much. And this will be recorded. This is getting recorded. So, by tonight, you will see right at the bottom of the module number 3. Bye-bye. Good night. Have a nice weekend and see you next week. If you have any question in between, you can ask me. Bye-bye.